Hello, Marcy and or TA. This is our presentation. It's on natural selection. It is me, it's Audrey Wright, Kaylin Osborne, and William King. We will all be presenting. With maximum survival reproduction, it is not just about being the fittest or just being able to survive or just being able to reproduce, but instead it is being able to survive and reproduce long enough to do that. And so it's not just about being strong or not being about the best specimen in your species, but instead it is about survival and reproducing. A good anti-example of that is the mule, which has a parent of a horse and a donkey, and it has the best traits from both, and even better. It's able to carry longer loads or bigger loads in proportion to its body weight, and it's not as stubborn as a donkey, but it's not able to reproduce, and therefore it is a not fit organism.
So our next few slides are going to be about evidence for natural selection. The evidence is so important for natural selection just like it is for every other scientific field, because it's through the evidence that we can test our hypotheses and show where our knowledge comes from. It's the evidence that supports the growth of our knowledge and our reasoning, and it allows future scientists to test what we've learned and claimed. The evidence for natural selection goes all the way back to when Darwin initially wrote on the origin of the species, and he first introduced the ideas of evolution by natural selection and adaptation and everything else. In his writings, he provided some evidence by citing comparative biology and the geographic separation famously of the finches and some other species in the Galapagos archipelago in South America. Nowadays, we have many more kinds of evidence and many more things that we've learned about natural selection because of it, but it was so important that Darwin was not silent about what he first learned and was willing to share his evidence and his knowledge with the world so that we can continue to increase the scientific field and to increase our understanding.
So, evidence of natural selection, the first piece of evidence that we have is artificial selection. So we as humans have selected desirable features in organisms, and we've continued to breed the organisms with favorable traits so that we can have their youth, their offspring, with those exact same traits. So an example of this would be dogs or apples or racehorses. For example, with dogs, cuteness, fluffiness, how calm they are, how easy they are to play with are traits that humans have favored over time. And so we've kept breeding dogs that have those favorable trait features. And with apples, there's a bunch of different kinds of apples, like Honeycrisp or Gala, and we breed the apples depending on what kind of trait we're seeking for. And then with racehorses, we want the fastest horses to win the Kentucky Derby. So whatever horse wins the Kentucky Derby one year is bred with a lot of different horses to make sure that its offspring will then be able to hopefully win the Kentucky Derby the next year.
The second evidence of natural selection is comparative anatomy, where organisms that have similar anatomy to each other show evidence of a common ancestor and therefore natural selection. An example of this is homologous structures, where each of these have similar bone structures, yet they very clearly have different purposes in a wing and a flipper and a hoof. Another example of this is the vestigial structures, where some organisms continue to maintain structures that they no longer use, and it makes no sense for them to have it unless there is a common ancestor that is left over. An example of that is the whale with pelvic bones, where we as humans use them, and whales have them, but they don't use them, and so it's evidence of that common ancestor.
Okay, and then another is embryonic natural selection. So this is like the idea that we all connect to one common ancestor, which is not shown with like a mature body of an organism, but you can see that with the embryos, they all look pretty similar, even though there's fish, chicken, pigs, and humans. And so you can see that the structure of the embryos is all very similar because we have that shared ancestor, but as it develops through time of the development of the embryo, you can see that at the beginning there's tails and kind of like slits for gills, and as it goes on, the human here, the tailbone gets smaller, where the fish has its tail. And yeah, so embryos often will retain the leftover traits from common ancestors, which is why we still have a tailbone, but we don't have a tail like a fish.
Okay, so another example or another piece of evidence of natural selection is geographical evidence. So geographical evidence shows natural selection because organisms evolve differently when they're isolated in different environments. An example of an isolation of a population would be marsupials in Australia. So those would be things like kangaroos or koalas or wombats. They have unique features that are very specific to marsupials. One of them is giving birth to their young, and then their young climb into their little pouch and stay there until they are fully grown and able to live outside of their mother's pouch. Because Australia has unique conditions, like it's very dry and it has very different plant life than other continents, marsupials evolve differently than mammals on other continents and have unique features because of it.